shift. Okay, the researchers conclude that such a shift is in progress, and there is a strong probability it will continue. According to an analysis published in Environmental Research Letters, a study which relies on advanced modeling use artificial intelligence and machine learning doesn't conclude that corn and soybean production will cease in traditional growing regions of the Midwest. Rather, it signals that farmers will need to adapt to changing conditions over the next several decades. We're not suggesting that such a shift would be catastrophic, said Armin Kamenian, Associate Professor of Production Systems and Modeling at Penn State College of Agricultural Science. The changes are likely to be gradual, and farmers and the supply chain will be able to adapt, but things will change. Farmers already besieged by extreme weather and economic trend may need to adopt farming practice and other adaptive measures. They might plant 2 crops in a year, for example, or growing a greatly diversity of crops instead of a long-standing practice or rotating between corn and soybeans. The researchers said 3 crops evaluated in the study: corn, soybeans, and sorghum have distinct responses to humidity and temperature. According to lead researchers Alex Hoffman, in general, corn needs more humidity, sorghum tolerates high temperature, and soybeans need a combination of both.
The researchers conclude that such a shift is in progress, and there is a strong probability it will continue, according to an analysis published in Environmental Research Letters. The study, which relies on advanced modeling using artificial intelligence and machine learning, doesn't conclude that corn or soybean production will cease in traditional growing regions of the Midwest. Rather, it signals that farmers will need to adapt to changing conditions over the next several decades. They are not suggesting that such a shift will be a catastrophe, and said Armin Kamenian, Associate Professor of Production Systems and Modeling at Penn State College of Agricultural Science. The changes are likely to be gradual, and farmers and the supply chain could be able to adapt, but things will change. Farmers are already besieged by extreme weather and economic strain may need to adapt farming practices and other adaptive measures. They might plant 2 crops in a year, for example, or grow a greater diversity of crops instead of a long-standing practice of rotating between corn and soybean. The researcher says 3 crops evaluated in the study, corn, soybeans, and sorghum, have distinct response to humidity and temperature. According to lead researcher, in general, corn needs to be humidity, sorghum tolerate higher temperature, and soybean need a combination of both.